variables a and b represent positive integers greater than 1. 3a is the square of a whole number, and 4b is the cube of a whole number. What is a plus b? Let's begin by writing out what we know. Here's what we know. Since m and n are whole numbers, we should start with the whole numbers for m and n, then solve these radical expressions for a and b, searching for values of a and b that are integers greater than 1. Let's start with the first expression. The square root of 3a equals n, where n is a whole number. So let's start by listing off some whole numbers for n. 1, 2, 3, 4, and so on. After that, we'll square the value of n, and this will compute our values of 3a. Lastly, we need to divide by 3 to arrive at our values of a. Since we know that a is an integer greater than 1, we can rule out most of these candidates, and we're left with possible values for a being 3, 12, or 27, or some larger value. We'll perform a similar analysis to find some values for b, beginning with listing out values of m from 1 to 9. Next, we'll cube these values of m to get the values of 4b. And finally, we'll divide by 4 to get the values of b. As before, we can rule out any non-integers in the b column, which leaves us with b possibly being 2, 16, 54, or 128, or some larger value. The problem asks us to find the value of a plus b, which could possibly be 5, for example, if we add up 3 plus 2. However, 5 is not a solution provided, so we'll search again. And after a quick search, we realize that 12 plus 16 equals 28. The answer is C.